All right, guys, we're going to do, excuse me, Section 4 of Unit 3, Graphing Functions. Okay, so imagine scientists can use a function to make conclusions about the rising sea level. Sea level is rising at an approximate rate of 2.5 millimeters per year. If this rate continues, the function y equals 2.5x can describe how many milliliters y sea level will rise in the next x years. So, some of you always say, Ms. McCrory, when would we ever use this in a real world situation? Well, here's an example, okay? So, one way to understand the functions such as the one above is to graph them. You can graph a function by finding the ordered pairs that satisfy this function. Graphing solutions give a domain. Okay, so that's what we're going to do today. Graph the function for the given domain. Okay, so here's your function, and here's your domain. What we need to do is we need to first solve this equation for y. Okay, so we need to isolate this y. So we need to get rid of this positive 1x. Inverse is subtract 1x. Now remember, that's a negative 3. So I have negative 3y equals, these are not like terms, so I can't combine them. So I have negative 1x minus 6. Okay? Move this over. Negative 3y equals negative 1x minus 6. Okay. Now, the inverse of multiplication is divide. Remember, I'm trying to isolate that y. I have to divide each term by that negative 3 on the right side. Negative 3 divided by negative 3 is positive 1. This cancels out to y. Negative 1 divided by negative 1/3, or negative 3 is positive 1/3. This is a negative 6. Negative 6 divided by negative 3 is a positive 2. Okay, so now I have my function. Okay, substitute the given value for the domain of x to find the values for y. All right, so guys, we're going to substitute our input for x here. So we want numbers compatible with 1/3. So what would be easy numbers that are compatible with 1/3? Well, we always want at least one negative. So let's do multiples of 3. So we can do compatible numbers. So we can do like negative 3, 0, 3, and 6. Okay, so here's our input. Here's our function. And then we're going to get our ordered pair so that we can graph this, which is what we're trying to do. So for our domain, our input, we're going to input these values. Okay? So, now we need to find out what y is. So when x is negative 3, well, 1/3 times negative 3 is negative 1. Negative 1 plus 2 is 1. So y equals 1. So for our first ordered pair to graph, x is negative 3. Y is 1. Now we're going to input 0 for x. 1/3 times 0 is 0. So 0 plus 2 is 2. So when x is 2, when we input 0, our output y, when we input 0 for x, our output y is 2. All right, now we're going to input 3. 1/3 times 3 is 1. 1 plus 2 is 3. So our x is 3 and our y is 3. Now we're going to input 6. So 1/3 times 6, which is we input 6, our output is 4. Now we have 4 points that we can graph. Okay? Here's your x and your y. So our first ordered pair is -3, +1. Second one is 0, +2. Third one is 3, +3, 1, 2, 3. And our last one looks like it's going to go off the chart. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It's going to be about right there. Okay. Now, we're going to do the same thing we just did. And it's going to tell you what to input for your domain. So I'm going to be quiet and let you all work this one on your own. If you get stuck, you can look up here. Okay, guys, I want to explain something on this one. When your function has x squared, you're going to be graphing something called a parabola. And you should have talked about this in your pre-algebra class, okay? A parabola is going to look like a U, all right? So if you notice here, when I substituted in -2, well, -2 squared is +4, so my output was 1. So when I substitute in +2, I'm still going to get 4. My output is 1. So once you get familiar with this, with your parabolas, you really only need to do the top 3 because then you know what your output, your y value is going to be. See how they're the same? All right, let's move on. Okay, on number 2 here, before we can graph it, we need to solve for y because it's not in our function order, okay? So let's do that first. we're trying to solve for y, which means isolate y. So this is a negative 2x. We need to add 2x to both sides. So this cancels out to y. Over here, I can't say 3 plus 2x is 5x because they're not like terms. So I have 2x plus a positive 3. Now if you want to write y equals 3 plus 2x, you may, but I'm trying to get it in a slope formula form so you all get used to it. When we get to chapter 4, it'll be a little bit easier for you, okay? All right, now we have our function. Actually, let's use this first one. It's telling you what to input for your domain, which is your x. And then you all should be able to take it from here. We're going to input negative 5. 2 times negative 5 is negative 10. Negative 10 plus 3 is negative 7. So our first ordered pair is negative 5, negative 7. Input negative 3. 2 times negative 3 is negative 6. Negative 6 plus 3 is negative 3. Then we're going to input 1. 2 times 1 is 2. 2 plus 3 is 5. And then we're going to input 4. 2 times 4 is 8. 8 plus 3 is 11. Okay, so let's see here. We have, let's label these tick lines. Here's your center point, your origin, that's 0. So let's label these. Every tick line is going to represent 2. Okay? All right, so we have negative 5, negative 7, negative 5. All right, so negative 5 is between the negative 4 and negative 6. Negative 7 is between the negative 6 and negative 8. And then we have negative 3, negative 3. Negative 3, negative 3. And then we have positive 1, 5. And then we have positive 4, 11. And there's your line. Now, we'll go back up here for a second. Oh, messing it up here. All right. Well, I'll explain that in a little bit since that messed up. All right, let's move on. All right, guys, I'm going to need to stop this and do a part 2.